Hello, good evening, guys. Hello, good evening. So, today we'll be discussing about as discussed and as planned. We'll be discussing problem statistical inference, including both estimation and testing hypothesis from past papers of IIT JAM. So, we have selected 2020 wala here because it's the most recent one, and we also understand and we will solve the problems together. Okay. So, good evening, all of you. And yeah, welcome to Change the Statistics Department. If you're new to our uh, program, seeing it online. Okay, so let's start. Let's wait for a few minutes for our students to join. Hello, Hemant. Hello, Haraj. Yep. So let's start. Debargo is here. Prajit Debargo, who all are here. Oh yeah. So let's start the class. And since all of you are here, happy New Year to all of you. Most of you are here. I mean, happy New Year to all of you. And let's start the program. Okay. So yeah, hello Naresh. Hello. So let's discuss the first problem. It's a first statistical inference problem in the paper of 2020. The problem talks about um, if x1, x2, xn are random sample from uniform theta minus 0.5 to theta plus 0.5, then like where theta is a real number, then if x1 is the minimum of xi's and xn is the minimum of maximum of xi's, then which one is the following estimate, not the following estimator, MLE estimator of theta. So when you are doing MLE problems, guys, the hint one is that instead of applying formulas, so if it's a straight away, formulas will not be even usually. Okay, so what you need to do is the following: you need to draw and do it from the basic principles, because you will be given unknown distributions, okay, with different and which much more difficult parameters, basic principle. So what is the basic principle? The basic principle is the following: is that just write likelihood, guys, just write the likelihood. So likelihood of theta given the data x curl is what is so we have to write the first likelihood of the data. So f of x is what? How can we write it? F of x is 1 indicator. So it's indicator. When it's indicator, theta minus 0.5, that means it's less than the minimum, the first order statistic, and xn is less than the maximum order statistic, is less than theta plus 0.5. So theta minus 0.5 is less than equal to x1 and xn is less than equal to theta plus 0.5. Okay, so you can also write it as indicator, although it's not a random variable, but yeah, indicator x1, तो थीटा का बाउंड देते हैं, x थीटा लेस देन इक्वल टू व्हाट, x1 plus 0.15 and is greater than equal to xn plus 0.1 0.5 I mean. Okay, hello guys, yeah. So let's say you will get the likelihood as indicator. Rather, it should be yeah, it should be, actually I have written the likelihood over here. Okay, it's actually not like not the effects but likelihood. So this is the likelihood over here. Okay, so I should have written it here. See, it's indicator, the xi is greater than equal to that thing. So it is indicator fx is equal to indicator x less than equal to 0 point is theta plus zero point 0.5 and greater than equal to theta minus 0.5. That is the indicator. Now here is like indicator theta less than equal to x1 plus 0 0.5 and greater than equal to xn minus 0 0.5. So you have to draw the diagram now. If you draw the diagram, right? So how will the diagram look like? The L theta comma x, it's a function of theta. Likelihood will look like 1. So here two numbers, x1 plus 0 0.5 and xn minus 0 0.5, and it is 1 over here. So therefore it has no, as it has no unique um like no unique like corresponding MLE. Why no unique corresponding MLE is there? Because it, because the idea that the all the like portions, right? It's maximum in all the portions. It's maximum in all the portions. So that's for what we will do. We'll do the following. So therefore, the natural question: what is the MLE? So Devarga has told that the MLE is this, but naturally, what is the MLE? Okay, the MLE lies therefore which, so points that is lies between, right, every single number, right guys? So you have to just check which number lies over here and which number really lies in, don't lie in this region. Okay, that's what we have to check. Okay, that's the thing, that's the only thing that we have to check now. So in this region, let's check. So you have to check which number doesn't lie in this region. So we check it. So that's a very important question. How do we check it? So that the first number lies in this region because also that xn lies over here. X1 and xn lies in different places. Okay, I mean x1 and xn lies in different places. So therefore, x1 xn lies like this. X1 and xn maybe. I'm not sure. Yeah. So you have to just check. How, right? So just mathematics. How do you check it? So here it's, you have to check, it's suppose it's a plus, you have to check whether it's a minus 0.5 and b, sorry, b minus half and a plus half के अंदर a plus b by 2 is there or not. Okay, similarly you have to check each and every single options that are there. Okay, but remember one thing, that the difference is 1. Okay, so therefore minus a is almost 1. So you have to use this idea and you have to check that which is really, easily understand from here which is really false. They were, so yeah, you can really check it, option D is false. I will not discuss further on. So I'm giving you the ideas how to do it. Okay, that's the entire thing. Any doubts, guys? Do you want me to further on? Okay, let's move on to the next problem, guys. Let's move on to the next problem. Okay, let's move on to the next problem, guys. So, problem number 28 now. X1, x1, x2, xn are random sample from exponential theta distribution, and theta is a if not non-negative but a positive integer. Okay, so if x bar is the given, then what is the 95% confidence interval for this? So you have to, let's check. What do you have to check? So 95% confidence interval for theta, right? So how do you check it? Whether you take for exponential, best, what is the best estimator in some sense? It's x bar, right? X bar. What do you think? So how do you really find the best in this sense, guys? So how do you really find the best estimate? So you have to choose x bar, right? So how do you choose it? Or you want to tell gamma 1 comma theta? Ah, perfect. 2 theta x1 follows chi square 2. Perfect. So someone told 2 theta chi square 2. Why is that true? So you have to understand the relationship with exponential. Okay, exponential with gamma and x square. How it's related. You have to understand this very thoroughly. Okay, how it's related? Try to understand this. So exponential theta is same as gamma 1 comma theta, and gamma 1 comma theta is chi square. So comma theta nahi. I mean, if you just multiply by theta twice now, twice theta gamma 1 comma theta chi square. Perfect. That's a perfect. Okay, and you just, if you add it up all, you get 2 times n follows sum of independent chi squares is chi square, right guys? Chi square twice n. Perfect, Kakali. Thanks. So that's what it follows. X bar is the, okay, so it can be it's complete sufficient too. So you can really, and most importantly, it's a complete sufficient. Sufficiency matters mostly because, as you know, that as I have discussed, that naturally occurs in the corresponding testing hypothesis perspective. Okay, yeah. So therefore, you get 2n, and using this, we can solve the whole thing, right? So how do you find it? It's really easy. So it's and therefore it's 95% confidence interval. So how do you find it? Low. So therefore prob theta is greater than this and less than something. What is that chi-square value? Such that that should be the chi-square value, right? No. So essentially you want some C over here, 95% interval, right? Confidence interval. So therefore, what do we want? That twice x bar is less than C twice theta x bar n. Well, you know this follows chi-square twice n. Same as probability 0 less than chi-square than this C2 theta times n is equal to 95%. And you know what is this? So therefore you want to find this stuff that is 90% interval. So this is 95%, therefore tell me this will be chi-square twice n 0.95, 0.05 or 0.95, tell me. Perfect. So after this it will be 0.9. You want 0.5, right? 0.05. So it will be, this will be therefore, so after this you want 0.05, right? So therefore this will be twice C theta x bar times n will be chi-square twice n 0.05. So therefore you get that theta, this C rather is equal to, oh, so theta will not be there, I'm so sorry, theta will not be there. This will be C is equal to chi then 0.05 twice C n twice, okay, therefore it will be this one C. Perfect, right? So this is how you do the problem. Okay, it's a really easy problem, guys. So let's, okay, all of you understand, guys? All of you understanding? Is it fine for you guys? All of you understanding? Sound fine now, guys? Next problem. I think we have done this problem earlier. Let's check it now again. So I think we have done this problem. Anyways, let's do it again. So let's do it very quickly. So essentially it will be, we will be doing really the uniformly powerful test, and we know that for this test I have done by calling what will be the fact that essentially the Neumann-Pearson lemma wala test will all essentially the most powerful test over here. Okay, so the Neumann-Pearson lemma wala test will be the most essential. Rather what you will do, you will just assume theta is equal to theta 1 here and you do the test. Okay, you just assume any constant not equal to C greater than 1 and you just do the theta 1 to be the constant. Okay, and you will do the test. Okay, so how do you do it? So step 1 is consider theta equal to theta 1 and do the test. Okay, so Neumann Pearson lemma test. So how do you do it? So f of theta is equal to 1. Product of like likelihood of theta is equal to 1, I mean. X bar, sorry, yeah. And likelihood of theta is equal to theta 1. It's equal to theta to the power n, theta is a 1 to the power n, it will be times 1 minus, so it will be product of I from 1 minus xi whole to the power theta minus, and similarly here down it will be theta 1 to the power n pi of 1 to whole to the power n 1 minus xi whole to the power, here theta is equal to 1, so it will be 0, it will be 1 just. Rather I could write it over here, it will be just 1, and here it will be just theta 1 minus 1. Okay, and this must be what? Under h naught we will reject if this is 2 less than some k. Okay, and therefore what we will do the following, that it is the same as telling that what, so we will put in some log over here now. Okay, so this is same as, observe this is same as telling this is equal to 1, and this will become what, this is a constant, right? Vanish to that side, so it will let it be k dash, and yeah, this is the entire thing that will be there. Okay, so let's take a log now. If we take a log, we'll take log and make that vanish. Okay, so one thing we'll just see that this is a beta, so xi follows what, xi follows beta. Do you remember guys what is this? Xi follows beta. Remember what is this? Xi follows beta. So yeah, so when you observe, essentially it's all about, I have also seen in ISI MSAT problems also, it plays around with the probability distributions. So you need to know the relationship between the probability distributions very well. So that is really, really important for to understand this very in a much more like much more deep format. Okay, so how do you do it? Tell me. So we have done this. So let's take a screenshot of it. Exactly. B, it follows beta 1 comma theta. Perfect. So observe this, that the x follows beta 1 comma theta, 1 minus x follows beta theta comma 1. Okay, and therefore what happens, minus log of this, so here is the result, if x follows beta then minus log of x follows exponential alpha, and therefore minus log of 1 minus x follows exponential theta. If 1 minus x follows this, and minus twice log of x follows exponential twice theta. Okay, and then essentially twice theta means so essentially we have also seen that it follows gamma 1 comma theta. So we have also seen it follows chi square 2. Okay, so therefore what does it follow? Minus twice gamma follows summation of this gamma n comma theta. Okay, but this is not really happening over here. Let's see what really happens over here. So it's actually following the same remember, it actually is also followed the same principle, same relationship over here. So it's sort of kind of important. Okay, remember this relationship. And therefore what happens, that under h naught when theta is equal to theta 1, so okay, let's try to see this. So what is really happening? So when you just so therefore this is happening, so therefore you just take minus log of it. Now you just take minus log of it, what do you get? So you get twice of this, so you multiply 2 with this. Okay, let's not multiply this, but let's take log first. So minus turns out minus summation ln 1 minus x times some constant, that constant goes to that side, is greater than less than equal to k double dash, say. Now we see that minus twice summation log makes sense, which this now follows some k double dash, this form follows chi square n under h naught. Okay, because then it follows uniform. Okay, that's the idea, then it follows uniform. And therefore what you get over here is that chi square is less than equal to k double dash. Okay, that is the, so therefore you get this test statistic over here. Now you want to reject this at the alpha level of significance, you get that, therefore this is the test statistic. Now you want to reject that, reject this when this is equal to k double dash. Now you want to find that alpha level of significance. What is this? So probability of rejection is k dash, so you set k double dash as chi square 2n alpha. Okay, wait, chi square 2n alpha. Wait. So let's see the diagram now. Chi square 2n alpha. So we will reject this when at alpha level of significance. So here it's alpha here. So therefore it's 1 minus alpha here. So therefore it's chi square 2n alpha. Perfect. So this is the idea. Right, guys? Any doubts, guys? Everything clear? So therefore we get this result. So therefore it's kind of important also. So let's move to the next problem. So what we have used here, we have used MLE wala concept, we have understood the relationship between distributions, we have understood what is the confidence interval. Okay, we get a sufficient statistics, we take the sufficient unbiased UMVUE, whatever it turns out, usually it will turn out to be good, and we take its confidence interval. Essentially it turns out to be a play of probability. Okay, here also it turns out to be a play of probability after you just do the corresponding calculation and name and Pearson lemma. Okay, so let's move to the next problem, guys. So you have done 3 problems in 30 minutes. That's quite good. 10 minutes. I mean, therefore, we can do around 1.5 hours, 99 problems. So we can complete this paper, I guess. Let's see. So we have 2 probability density functions, PDF now. Okay. And X is a random variable with PDF this. Essentially, again, it's name and Pearson lemma, NP lemma. Okay. So observe that it's just H naught versus both are simple hypothesis, right? And name and Pearson lemma tells the same thing. Just like that. So how do you do it? Just apply name and Pearson lemma now. So if you apply name and Pearson lemma, let's see for which of the following authorities randomly selects the most powerful test with reject. So UMP is the most powerful test. So let's try to find out this. Let's try to find this out. Okay. So say f naught x by f1x f naught x by f1x is turning out to be So it's only defined within, it's let's not define somewhere else. So it's only defined within x less than equal to 1, x not less than equal to 1. So let's not worry otherwise. It's not defined otherwise. So it's equal to twice x. Perfect. It's defined twice x between 0 and 1. Perfect. That seems good. So therefore this is the name and person. So we will reject if it's less than equal to k for some x. So therefore also this is not true because okay, it's only random variable x. So we are only observing 1. So now perfect. So it's essentially equal to okay. So now we want to find the probability at which twice x is less than equal to this k is equal to what? We want to reject as 0.5 level of significance. So we want to reject this as, so therefore it will be less than equal to k is 0.05, right? Less than equal, I didn't get you. Greater than k? I didn't get you, Devargo. Okay, yeah, f0 by f1 is less than equal to k, okay. So therefore it's 0.05. So let's try to understand, let's try to, therefore it's an integration, right? So it's 0 to k twice x is equal to 0.05. So if you get that x square is equal to, therefore k square, k is equal to root over 0.05. So therefore you get probability x is less than equal to root over 0. So therefore reaction region is this. Twice x is less than equal to 0.05, right? This is a rejection region. So you have to find out for which values you're gonna reject this. So therefore x is less than equal to root over 0.05 by 2. So which follows of x? We're gonna reject h naught. So let's find out root 0.05 by 2. Let's find out its root 0.05 divided by 2. We get the following. Let's check. So we've understood the algorithm, guys. We are to finding the now alpha level of significance under h naught. So under h naught, we will reject when this, right? We have to find that case. So this is the alpha level of significance. We have probability of rejection given h naught is true. That is fx follows twice x, right? Therefore we follows, that is fx, x follows fx, f not x. That's why we do this, right? And therefore we get the alpha level of significance. Now 0.05 is 0.23423 divided by 2, we get 0.1111, right? Are you sure I have done some mistake? I think I surely must have done some mistake. Square root of 0.05 by 2 आ रहा है ना? Have I done some mistake? Square root of 0.05 divided by 2. Have I done some mistake? I think I should have done some mistake. 0.05 by 2 is coming out to be, anyways, it will come out to be, I think it's okay. So let's check this. Okay, I think it's a calculation error. It's twice x, na? Probability twice x less than equal to k. 6 less than equal to 0.05 by 2, right? Am I doing something wrong? Am I doing something wrong? Let's check. Let's check. You understand? Am I doing something wrong, guys? Am I doing something wrong? 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 Am I doing something? Yeah, I computed k. So we have got the k na. So now the rejection region is twice x less than equal to k na. Rejection region. It's twice x less than equal to k. Right. Yeah. Yeah. Okay. Anyways, let's move on to the next problem. I think I have done some mistake. I will come back to this again. Let's not waste time. Okay. U follows f5 comma 8 and v follows 8 comma 5. Okay. So do you remember the definition of f statistic? What is the definition of f statistics? Do you remember, guys? Do you remember f statistics, guys? Right? Okay, so let's move on to the next problem. So I hope you remember the definition of, yeah, by chi-square root over chi-square by m by root over chi-square of m by n is f statistics, right? Right. Perfect. So therefore, how do you find the f statistics now? Like, how do you? What is the relationship between this now? Tell me. So I think it's a, yeah, it's on root over maybe, yeah. Exactly. So therefore, if fn follows, so therefore 1 by fn, perfect. So since it's chi-square ratio, so 1 by f comma n, fm comma n follows fn comma m, right? So we can use this property. So therefore, what do we get? 1 by u is same as, no, 1 by u is similarly distributed as v, right? We can use this. So therefore, probability u greater than 3.69 is equal to 0.5. Okay, we can sort of use this as probability 1 by v greater than 3.69 is 0.5. So also what you get, probability v less than 1 by 3.69 is 0.05. And also if you just subtract it, probability v greater than 1 by 369 is 0.95, right? 1 minus this probability. So therefore you have to just calculate the c is same as therefore 1 by 3.69. Why? Because f statistics is ratio of 2 chi-square, right? F statistics is just ratio of 2 chi-square. So chi-square m by chi-square m ka by like chi-square m by m by chi-square n by n. follows f m comma n. So now chi-square n, so if you just do it 1 by, it becomes f n comma n. So it's a really easy problem, right? It's really easy problem. So 0.369 will come around 0.27. It's a really easy problem. Just see, everything is just turning out to be a really knowledge about probability distributions, guys. Okay, just easy probability distributions, guys. Okay, so we are using that chi-square m by m by chi-square n by n. Okay, इसका ratio लो, so it becomes chi-square n by n by chi-square m by n, m, right? So which becomes f m, just m and n just replaces, right? So therefore 1 by fm comma n follows fn comma n. So that is the relationship it's using here. Very easy stuff, right? Very easy stuff. So don't be afraid of IIT jam. It's really easy problem. Just you have to just think a little bit quickly, okay? And have a quick calculative mind. Perfect. I think this class will be getting over quickly, I guess. But yeah, I think we can like do all these problems, more than 10 problems, I guess. Yeah. So let the sample mean based on random sample from exponential lambda be. So x bar is equal to 3.7. It's given. And the MLE of this, what is the MLE of this? So remember, so the result. If MLE of theta is theta hat MLE, this implies that MLE of f of theta is f of theta hat. It's called the invariance property of the MLE. Okay, see, if it's called the invariance property of the MLE, what you can get is that this implies that इसका MLE estimate is equal to 1 minus e to the power minus lambda hat ka MLE. Now what is lambda hat ka MLE? Lambda hat ka MLE is what? Is x bar, right? So it's 1 minus e to the power minus x bar. It's just application of a one result. Exactly, invariance property. Perfect. Very easy problem, guys. Very easy problems. Okay. And yeah, perfect. So let's move on to. So therefore, what do we also just can find out? Okay. Let's not do this like crunch it further. Let's move on to the next problem. Let's see what awaits for us. Perfect. So see, again we will see. See, we have two type of problems in statistical inference as we are seeing. One type of problem is just doing from the basic scratch and just calculating some likelihood and MLE stuff, and some applications really easy results, and some applications of this basic probability distribution. This is really important. See, probability relationship is really important. So you have to just apply this instantly. Okay, really easy stuff. So x be a single random observation drawn from uniform 0, theta distribution, and again it's a C. It's another test simple versus simple. So just apply Neyman Pearson lemma right there. So Neyman Pearson lemma ka statement apply karo, so you get a test at least. But read the problem first. Okay, it's given the test procedure rejects h not if and only if x is greater than 0.05, 0.75. So if it rejects that, then what will happen? X bar greater than 0.75, that is a rejection region, right? And what will you test over here? So let's see. So therefore, what is the probability of type 1 error? Alpha and beta. So therefore, we need to find alpha and beta. So probability of rejection given theta is equal to 1 is alpha, and probability of not rejection given theta is equal to 0 is beta, right? Given h1 is true, it's not rejected. Am I right? Yes. So let's calculate it. Therefore, rejection region is what? It's probability x greater than 0.75. That's a rejection region given theta is equal to 1. And probability x less than equal to 0.75 given theta equal to 2. Right? Just easy stuff. So therefore it follows, x follows uniform 0 comma 1 here under theta is equal to 1 given theta is equal to, and here x follows uniform 0 comma 2. Therefore what do we get? We focused. That means it's 0.75 by 2. Right? And here it's 0.25. So add it up. You can get the values, right? Very easy stuff. Just basic definition, guys. Just easy basic definitions. Okay? Just easy basic definitions. So it's easy. So it's a basic understanding of, it's like test of hypothesis basic. Okay, let's see the properties here. Here it's what? It's just basic MLE invariance. Okay, here it's what? F distribution, sample statistics problem, actually it's it. F distribution. Here it's what? It was a, this was, I think, was the most difficult, not the difficult. Here it's basic NP lemma, name and Pearson lemma, basic stuff, basic NP lemma application. Here it was a bit twice NP lemma versus beta gamma exponential and chi-square relationship. Okay, and here it was just basic confidence interval, sufficient statistic, confidence interval and sufficient statistic. Rather, it's just x bar theta ka value. Okay, sufficient, and again chi-square gamma exponential beta ka relation, gamma exponential ka relation. Okay, and here it is just basic MLE. Okay, and understanding basic MLE is understanding of MLE. Okay, and what is really happening. So we're really just like distributing all the topics over here. Okay, it's really easy, guys, so don't worry about this at all. Okay, so let's do this the third last problem of 2020. So x1 is equal to 1, x2 is equal to 0, x3 is equal to 0, x4 is equal to 1, x5 is equal to 0, x5 is x6 is equal to 1 is data on a random sample of size 6 from binomial 1 comma theta. Okay, but theta is equal to 0 comma 1. Then the UMVUE of unbiased estimator of theta plus into 1 plus theta. How do you calculate that? The problem is not here. The problem is how do you calculate from x1, x2, xn, which follows binomial 1 Bernoulli theta rather. Okay. How do you calculate the UMVUE of theta into 1 plus theta? That's the intricate question over here. How do you find this? Here comes the application of applications of sufficiency, completeness, Rao-Blackwell theorem, and this stuff. So any ideas, guys? How do you continue this? So I think this is one of the second most difficult problem of statistical inference. It requires some deep implications of like applications of statistical results. Yeah, but how do you know that that's the UMVUE? That's the question. Okay, yes, perfect. So the first step is theta. Remember, first step is that how to use this. X bar is complete and sufficient for theta. Okay. And now what we will do, we will find the t of x bar such that we will find a function of x bar such that expectation of the t of x bar is equal to theta into 1 plus theta. Why? If we do that, then by Rao-Blackwell theorem, expectation of tx gives, so therefore by Rao-Blackwell theorem it will imply that t of x bar. Therefore that is the idea. Whenever you require to find some very different, very weird kind of parameters, is the Rao-Blackwell theorem. So just remember the result. Weird approximation of UMVUE. Just remember, find the complete sufficient statistic and find a function of x bar whose expectation is that weird f of g of theta. Okay. So it follows by Rao-Blackwell theorem, rather Rayman-Chaffee, that it's a UMVUE. It's really important to understand. It's perfect. Very good. So let's try to find that t. How do you find that t? So expectation of x bar is, so see, observe, we need to find two stuff. We need to find for theta and we need to find for theta square, right? So now how do you find for theta square? How do you find for theta square? Let's try to understand this. So perfect, very good. So where does theta square comes up? Theta square comes up from 1 minus theta into 1 minus theta. Remember, this was the variance whole expectation. Here we need to do a plus theta square, right? So if we plus twice theta square rather. So how do you find this stuff? That's the idea. So we need to find that expectation of theta square comes up from variance part, right? So let's try to understand that how it comes up really. So let's try to understand this very carefully. Whew. So summation of xi follows binomial n comma theta. Okay. So theta hat is comes out to be, that is x bar. Okay. So expectation of x bar is theta, we get it. Expectation of x bar is theta. How do you find the expectation of variance? How do you find the expectation of variance? We need to understand that. How do you find the expression of variance? Sorry, expectation of x bar square, what will be it? It will be 1 by n square, expectation of summation of xi whole square, which is equal to 1 by xn square. Let's call it t. So 1 by n square expectation of t square. It's same as 1 by n square. So expectation of t square is what? Variance of t is equal to minus expectation of t whole square is expression of t square, right? So the variance of t is what? Variance of t is n into theta into 1 minus theta. Okay, np into 1 minus v plus minus exponent of t square, that is n theta, what I'm doing correctly, n square, wait, I mean n square theta square, okay, by n square. So what do we get? We get that theta into 1 minus theta. Okay, let's calculate this. Theta into 1 minus theta by n minus theta square. Okay, so okay, let's move it right in terms of theta n. So the expectation of, so it's theta by n minus theta square n plus, I guess, n square by n square. That is, you get theta by n minus theta square 1 plus n by n. Perfect. So now it's done. Why? Because it's equal to expression by n is what? Expectation of x bar by n minus theta square 1 plus n by n. So what do we get? One second. So what do we get? Let's write in a very well written format over here. So we get that, let's rub it all. I'm rubbing it, all of it. I'm rubbing everything out here. Let's rub this stuff up. So expectation of x bar is theta and expectation of x bar square minus x bar by n. Okay, here minus then plus whole times n by n plus 1 is equal to theta square, right? So now add it up. If you add it up, you get that expectation of x bar times, if you take something common, so that thing is equal to theta into theta plus 1. So you get a function here inside which is a function of theta, t of x bar, and you find that t of x bar is this. All of you understood this, guys? Or did I do something wrong? Yeah, I'm so sorry, guys. Yep, this will be plus. Okay, this will be then minus. So this will be square minus. Okay, perfect. Thank you so much. Is this, and therefore you get that. Oh, this is plus. Then this will be, sorry, this will also be different. Then this will be n square minus n, then n square minus n. If it's n square minus n, this will be n minus 1, and this will be n minus 1. No, n minus 1, this will be n minus 1. Perfect. All of you understood this is a really intricate format of how you really derive it. Okay, so you understood there are two aspects, theta and theta square. If it's done for other parameters, say for exponential, it can be given. For other stuff, or other single pressure, it can be given. You have to just understand the you have to use just two, like usually you have to use till the variance. Okay, not much more than. Okay. So there are the things you get, therefore you find it, and then you find out this t of x bar, and then you just put it over here. Okay, just easy stuff, guys. Okay, sounds good? Perfect. Here also it can be, instead of, since it's a function of x bar, it can also be given x bar is equal to this, but it's not given, so that you cannot understand. Okay, that's the idea. Although it's a really beautiful and intricate problem. I like this problem. Okay, these problems are really good. This problem and that problem. Other problems are really easy. Okay, may I move on to the next problem, guys? So your homework is to find out this t of x bar, what it is. Okay, find it out. Okay, problem. Okay, what's this? Let's see. X1, 2 random variables are 2, sample size is given. from point show theta, where theta is from 0 to infinity. So phi hat is a uniformly minimum variance unbiased estimator of psi theta, which is equal to this. Very good. Then psi hat is what? Interesting question. So how do you approach this problem, guys? Psi hat is uniformly minimum variance unbiased estimator of the psi theta. So how do you really find it out? Think about it, guys. I'll drink some water in the meantime. Okay. Okay, let's take the example. So here we have a random sample size. So let's not care about the random sample size. So we are really wanting to find a really weird estimator of psi of a function of theta. It's a UMVUE. Okay. So we want to find a function of theta. Remember the other thing also? If you want to find g theta, we want to find an x bar. So essentially we are trying to find psi hat, which is an UMVUE of psi theta. So what I will do is the following. The idea is the following. We have theta hat, UMVUE of theta, right? Right now what you do is that find t of x bar, sorry, t of theta hat. Actually we use the same principle in the other problem, t of theta hat, such that t of theta hat is a UMVUE, is a expectation laker. It's g of theta hat. Okay, right? So what do we get? So we know that I mean a function of a complete sufficient statistics also a complete sufficient statistics, right? So therefore g of theta hat is also complete sufficient for this parameter, for this g of theta. So therefore what do we get? Since the expectation is 0 by Rao-Blackwell theorem by Lehmann-Scheffé, we get that t of theta hat is UMVUE of G of theta. All of you understood this, guys? It's not Lehmann-Scheffel project, it's Lehmann-Scheffel. So you see the algorithm, right? It's an algorithm, right? So essentially this is the algorithm to find out. This is exactly the same algorithm we used here. Okay. So this is really important. This is really important. So it's the same algorithm we used here. So remember this algorithm. This algorithm is really useful. This is the algorithm. I call it. Let's call it the LS algorithm. Okay. This algorithm is really important. LS algorithm problem. So I will make a notes for you based on this all the algorithms and what is for the internal students of Chinta. Okay. Soon. So after my exams get complete. Okay, so as let's see what Debargo has told. Debargo has told that it's a probability. So let's therefore what we need to find? We need to find this t of theta hat. Now what is theta hat? Theta hat is x bar. It's a complete sufficient statistics of theta, right? So find that t of theta hat such that expectation of t of theta hat is equal to g of theta. Let's write g of summation of, essentially it's 1 minus probability. If you see the thing, actually 1 minus probability x is less than equal to 3 follows Poisson theta. And what is theta hat over here? Theta hat is x1 plus x2 by 2, right? It's also kind of probability x greater than 3. So what we can do over here? What we can do over here? So x1 given x1 plus x2 is Poisson. Are you sure? Do it. So essentially this is the idea, guys. You need to find some, we have x1 plus x2, in terms of that we need to find stuff. Probability x1 x greater than 3. So therefore somehow x2 you have to construct a Poisson. So therefore the idea is that you have to somehow using x1 x2 construct a new fresh Poisson. That's it. Somehow x1 plus x2 construct a new fresh Poisson. New fresh Poisson. How do you do that? It's a probability problem just. Okay. So therefore what do we get over here? So how do you find a fresh Poisson? This de Vargo's method work? Simple Jacobian, he says. But no, we want to make it easier, okay, much more easier. How can you do it? Think about it. So how can you do it easily? So Devargo is telling x1 given. So this is Devargo's thing. X1 given x1 plus x2 follows ratio theta. Is it true or not? That's the question. So x1 plus x2 follows what? X1 plus x2 follows point show e to the power twice theta, point show twice theta, right? So you want to remove the twice from here and want to get in terms of theta. How do you do that? You can find conditional, yeah. See, given x1 x2, okay, given x1 plus x2, I think it follows binomial, right, guys? It follows binomial theta by binomial half, it will follow, isn't it? Conditional, doesn't it follow binomial half? So conditional distribution of Poincare given Poincare distribution is binomial half. I will show you it. I mean binomial that thing. Yeah, so it's binomial, right? So what you told it's Poincare, right? How can you find the expectation then? The expected part of it. When to find it's essentially Poincare something. How do we find it? I'm sorry for this. I will soon see. 1 second, guys. Okay, he's saying of What is SCX? I'm not understanding. What is SCX? Can you make it much more clear? Hello. Okay, so S is equal to, okay, it's telling that probability half to the power S. What is S? I am not understanding. Can you write it down and send me understanding the barcode? Essentially, you have to find a function of x1 plus x2 which gives a Poincare directly. It is not true. This one is wrong. It follows binomial theta by that stuff. How do you find a fresh Poincare? Yes, so let's see it. Okay, so let's check it. What the Virgo has to say. Okay. What is S? S is x1 plus x2 and x is acha. I understand now. You mean x1? Is it x1? Perfect. So here, very good. So the Virgo is creating this new function from x1 plus x2, which is actually Poincare. Okay, let's see what he has to offer. Let's. It's problem 59. So I hope all of you understood what our aim is. Aim is x1 x2 theta. We need to create a Poincare x1 plus x2 का function which follows Poincare theta again. So let's see how it's given in the question. What is given in the question? I didn't get you. So therefore Devargo offers this. There are other UMVUEs also, or do you think there are other UMVUEs too? Maybe it's unique. Who knows? I mean, a raw Blackwell. I mean, Layman Chiffy tells it's unique. So is given in the wait. Just let me check once in the question. What is X? That's why I'm confused about the Virgo. So X, the Virgo is considering this any example X. That's good. So let's yeah. So let's think what you have done. So the Virgo has done this way. Yeah, perfect. So the Virgo has done this, that he has done by, so he has found probability of Sx comma S is equal to S is equal to x1 plus x2. Okay, and perfect, and therefore he has found out that what? So let's see this. He has found the following. So what is the new two things he are doing? He is doing that x1 is equal x1 is equal to what? X1 is equal to, okay, so to understand what is, he was doing probability x1 comma s. Okay, and what does he know? Probability x1 comma x1 ka thing. So we want to get x1 comma 2, that is x1 2. He wants, okay, wants to go there one from x1 comma x2. Therefore what is there? So x1 is x1 and x1 plus x2 is equal to x1 plus x2, that is, here it's, if it's considered u comma v, therefore v is equal to x1 plus x2. So how do you so Jacobian, as you have understood, Jacobian as you have written over here, let me write it over there, del u. So let's consider this u and v. Okay, wait, no, let's consider this u and v, and let's try to find out in terms of u and v here. And v is what? X1 plus x2 minus x1. Okay, what I am doing, I'm so sorry. Now consider this u and v. So u is equal to x1 and v is equal to, I mean, v minus u is equal to x2. So therefore if you find in terms of du and dx, so therefore du dx1, so what I am doing such a mess anyways. So we do d x1 d x1 dv dx2 du dx2 dv. So dx1 is 1, so it will be 1. Let's not rub it here, let's do it in the next part. It's equal to 1, and the x1 comma v is what? V is equal to x1 is what? It's 0, right? And the x2 is what? X2 is v minus u. So therefore it's minus, I think it's minus u is this, it's -1, and here it's VU. Perfect. So I was doing correct. I'm so sorry. Yeah. So therefore, determinant is 1, right? Positive determinant is 1. So therefore, what do we need to do it over here? Is the following, that probability on, let's see steps now. Probability x is comma x is this. To find the probability x comma 1 x comma x1 comma probability x1 comma x2 into Jacobian of that, it's probability x1 x2. So essentially both are same. So you can really find probability x1 equal to k and x1 plus x2 is equal to k dash is same as something like that, and you can find out easily that it's equal to e to the power minus twice theta e to the power whatever he has find out e to the power s. Okay, so he has find out that probability x comma s is e to the power minus twice theta theta to the power s, that is a v by x1 factorial minus x1 factorial. Okay, and therefore you need to find probability x given s. Probability x given s is probability x comma x by probability of s. So you just find it out, and he finds out it's 1 by s to the power s. So probability x1 given s, he finds out probability 1 by 2 to the power s, s choose x1. So therefore what comes up? Therefore he tells now that so therefore what he tries to find out now, probability x given s is, so now what he tries to find out is the following. But how do we create a new random variable of Poincare? Where is a new random variable of Poincare? Tell me. Where is a new random variable of Poincare? What is the new random variable of Poincare? He's telling that this follows this, but what is the new random variable of Poincare? How the new random variable of Poincare is coming up? Tell me, Degaru, how does it help? Why is the new random variable of Poincare coming up? Which is the f? Suppose f is this, so what is the f? Wait. It's UMVUE of Poincare function. Just wait a minute. Perfect. So understand this very. So we need to find expectation of t of x s, that is x1 plus x2, probability some Poincare random variable x greater than 3. Okay. So therefore Ts must be an indicator random variable, right? Indicator. Okay, something indicator, right? So that's the idea. What indicator? Because if it's indicator, then only it will happen, right? Indicator x greater than 3. Right? What is this x therefore? So that is the thing. It's expectation will be the probability, right? So what is the probability? That's what we have shown here. He has shown here. Let's see what he has shown here, and that's a very good solution. No, it's a sufficient answer of x1 plus x2. Okay, so when you do the expectation part, no, it can be x1 plus x2 and something else, but it's x1 plus x2 must be there. So fine, this perfect, this step is perfect, therefore you get the delta function is this. No, wait, I think there's some confusion over here. But what is the, I mean, I'm not understanding this thing. What you have done over here, Debarko. What does this help now? Where does this help? 1 by 2 to the power ss choose x. So we really want to find an indicator of Poinsot, right? So I am now understanding that wow, is this really an indicator of Poinsot? Hemant is a different. Okay, this thing is not correct because probability x1 greater than 3. I think there are some mistakes over here. No, wait. This is not equal to the given probability. I'm sure about that. No, wait. Am I doing something wrong? I'm just confused. Which is the test statistic? I mean, which is the not a test statistic that we are looking for? Hemant is a nice way of looking into it. But okay. Probability of x1 is equal to 0 by x2 greater than or equal to 4 by what is sir? The Prajat, what is your answer? Yeah, please read and send to the group. In the meantime, we have this problem here. Random variable n is equal to n theta 1 and its theta is equal to 0 versus theta to 0. And you know that when there is this is one sided test is not there, both sided test is there, it's a very easy stuff, okay? And the likely ratio test is Z test. So what is the Z test? The X bar test. So X bar minus 0 by let's see this x bar by 0 will normal 0 comma 1 by n, so it will be root n, okay, and it follows the normal 0 comma 1. So this is Z, and therefore the alpha level of significance 0.617 level of significance we rejected, so therefore let's see the test. Z greater than equal to Z 0 alpha by 2 and Z. So mod Z greater than equal to alpha by 2 it will be. Okay, and therefore you can get that this is the rejection region, rejection test, and therefore you need to find the power. Therefore probability, we accept h1 given h1 is true, that is mod Z greater than equal to alpha by 2, Z alpha by 2 I mean, okay, given okay, given theta is not equal to 0. So we need to find out theta is equal to 1, right? Theta is equal to 1 is given, therefore we can easily find it out that how will it happen. Given theta is equal to 1, we can really compensate that. So think about it and just calculate this, okay? It's really easy stuff to do. Just calculate this and it's just, let's go back to this problem, guys. Yeah, so is a general procedure of it. Okay, let's do this problem now. Okay, so yeah, so but I think like much more easier way. I mean, is this really needed? I don't sure. So from x1 plus x2 we need to find a point show. Let's see Hemant's solution once. So now find not a point show, find a, let's see what we need to find. X1 follows point show theta, x2 follows point show theta IIT. We need to find f of x1 plus x2 such that expectation of f of x plus x2 is equal to probability sum greater than 3. Okay, therefore f must be indicator sum x greater than 3. So they have to somehow find some function. So rather we should find out g of x1 plus x2 which follows x point show theta. If we find that, then we will say that g 3. We will easily say that, right? G of x1 plus x2 indicated that, then it will happen, right? So that's the idea. So how do you find that g x1 plus x2? What is that g? That's the question actually. So we need to find our g of x1 plus x2, that is follows point show from x1 plus x2 point show theta. But Prajat told something that he has in on his mind. Let's say Hemant's solution, but Hemant's solution is that working out, Hemant? And you want to find a probability such that think about this problem. Think about it, guys. I'm also thinking actually. Yeah, Hemant. No, see, Hemant. One thing one thing I'm not really understanding is the following: is that you have found out the probability, but I mean, one second, just but let me think. Hmm. I'm just worried, like thinking, why do you want to calculate like how? So essentially, my question is that how do you calculate this probability x greater than 3? How do you get this point show one? I'm not understanding from your solution. What is the point? Where is the point show coming up? And give me that found out the probability. That's good. But is that equivalent to expectation is same as summation of that stuff? That what I'm okay. Wait a minute. Just wait a minute. Expectation point show. Okay, that makes sense. I see, that makes sense. Wait a minute. Just when I think it's correct. Huh, I think this makes sense. Okay, so what is really happening over here? Okay, I guess it's correct. So what Hemant is trying to do is that probability x1 is equal to 0 is what? E to the power minus e to the power minus theta, right? But e to the power minus theta is coming extra, right, Hemant? Not correct. You understand the where the problem is happening? You understand what the problem is happening, guys? Yeah, please send it, Devargo. But do you think I'm not okay? Let's see one thing again. Do you think what thing was correct? Yeah. So tell me how will you do this problem, guys? Tell me. No, no. What you have done, we have understood. But my question is that my question is that del del 1 is equal to 1. Perfect. Probability x1 greater than 3. So I'm trying to express probability x1 greater than 3 in terms of x. Are you trying to make sense of probability x1 greater than 3 in terms of x? No, no, wait. My question is that why we are finding probability x1 greater than 3 given s? That's the question I have. So we're trying to the Vargas has found out that x1 plus greater than equal to x is some function of f of x1 plus x. That's okay. But my question is that why this is approximating to x1 greater than this? You understand my concern? Maybe okay. Just give me a moment. But just so what is the indicator function over here? What is the G for you guys? Debargo, tell me the G. Tell me the G. Tell me the G. Okay, Debargo. Yeah, I'm just interested in the G part of it. I'm just interested in the G. Tell me about the G, guys. See, what I am interested in this. Oh, no, G is essentially indicator x1 greater than 3. So is x1 greater than 3? So therefore we have to denote x1 greater than 3. Okay. So let's see. He's telling this is x1 greater than 3, perfect. So he's trying to find out that x1 greater than 3, rather x1 in terms of g of x1 plus x2. Okay, how do you exactly find that? But you're doing conditional stuff, right? Okay, so x1 in terms of x1 plus x2. So you find out probability x1 wait, you're telling, so what is the x1 in terms of x1 plus x2? So tell me which is x1 plus x2. Tell me the g. G is indicator of x1 plus 3, but tell me the function here. That is the function of x1 plus s2. So you're telling that x1 plus x2 is same as that stuff you have given. Let's see. But that is x1 given x1 plus x2, right? One by 2 to the power s. Okay, so he's telling that 1 by 2 to the power x1 plus x2 into s choose xi is same as xi given s. Same as xi given s, right? But xi given s greater than 3 doesn't, like, it's not same as xi, it's not same as xi greater than 3, right? I mean, xi given greater than 3 given s is not same as. Are you understanding the problem? I mean, let it be x1. Okay, let it be x1. x1 greater than 3 is not same as probability x1 greater than 3 is not same as probability x1 greater than 3 given x1 plus x2, right? because x1 plus x2 and x1 are dependent. It cannot be same. This event and this event cannot be same. Wait, it's getting confusing. See, you have calculated x1 plus x1 greater than 3 given x1 plus x2, right? This is what you have calculated, Devargo. You have calculated that x1 probability x1 given s is equal to this. That's what. But we need to find probability x1 greater than 3. Anyways, let's close the class here. We will discuss this problem in a new video, okay? Okay, otherwise it's like this video is getting longer. So we are left with one problem of 2020, which I will be going to discuss in. Okay, okay, let's see. Okay, so let's I will do this in a new video, okay? Perfect. Okay, bye bye and see you in the next class.